Hello everyone, I, Sonali Mate, welcome you all for the session of sliding contact bearings. The objective of a session is to understand the classification of bearings, to study the basic modes of lubrication. So we'll first talk about bearings. So what is bearing? It is a mechanical element that permits the relative motion between the shaft and the housing. So the functions of the bearing is, first, it takes up the forces that acts on the shaft and it transmits it to the frame or the foundation. It holds and guides the shaft in a correct position and it gives the smooth and free rotation to the shaft with a minimum friction. So these three are the main functions of the bearing. So we'll talk about classification of bearings. Now there are two parts. First is classification based on type of direction of forces acting on the bearing, and the second one is the friction. So in the first, the direction of the force. Now based on that it is radial and the thrust. Radial bearing and the thrust bearing. And based on the friction, they are classified as sliding contact bearing, which is also called as plain bearing, slip bearing or journal bearing. And the second classification is rolling contact bearing, which is also called as anti-friction bearing. Now the name implies this is a sliding contact and here it is a rolling contact. So in sliding contact the amount of friction is more. So they are also called as a friction bearing, whereas in rolling contact friction is less, or you can call it as anti-friction bearing. So here are the images of radial bearing and thrust bearing classification based on direction of the force acting on a bearing. Now here P is the force which is acting on a bearing. Now in case of radial bearing, P is acting in a direction perpendicular to the axis of shaft. It acts along the radius of the shaft. So the bearings which takes this radial force is called as a radial bearing. Whereas in this case of thrust bearing, the force P is acting along the axis of the shaft. So the bearing which takes up this axial force is called as a thrust bearing. Now talking about sliding contact bearing and rolling contact bearing. First, now in this diagram you can see this is a shaft, this is the bush, this surface is the bush, and in between bush and the shaft there is a lubricating oil. Now in this case, surface of the shaft, it slides over the surface of the bush. It slides over the surface of the bush. So due to sliding motion, there is more amount of friction and the wear. The sliding motion results in a friction and the wear. So to reduce the friction in between the shaft and the bush, lubricating oil is used. The layer of a lubricating oil is used in between this two. Now, in case of rolling contact bearings, here the rolling elements are used in the form of balls or rollers. Now, this sliding friction is converted into rolling friction over here. So, you can imagine here is a sliding surface and here is a rolling surface. So, here the contact between this shaft surface and this surface is just a point contact, whereas in this case there is an area contact. So sliding bearing generates more friction, whereas rolling contact bearing is having friction negligible. So these bearings are also called as anti-frictional bearings. Next is lubrication. As we have to discuss about sliding contact bearings, in which lubrication plays an important role in order to reduce friction between the sliding surfaces of the shaft and the bearing. So we'll see what is lubrication. It is the science of reducing friction between two bodies having relative motion between them by means of a substance called as lubricant. Now the functions of the lubrication is to reduce friction, reduce or prevent wear, to carry away the heat generated due to the friction. As excess amount of friction is there, so there will be more amount of heat generation. And to protect journal and the bearing from corrosion. Now we'll discuss about modes of lubrication. First is zero film lubrication. Now zero film lubrication, it means there is no lubricant used, a bearing which operates without lubrication. Hence it is called as zero film lubrication. Next is thick film lubrication. Now in this thick film lubrication, it describes a situation that when the two surfaces of the bearing are in relative motion and they are completely separated by a film of fluid. So in this case what happens? There is no actual contact between the two surfaces because there is a fluid in between them. So as there is no contact between the surfaces, the properties of surface like surface roughness or surface finish will have no influence. It does not have any influence on the performance of the bearing. Basically it depends on simply the fluid which is flowing in between them. Hence you can say viscosity of a lubricant affects the bearing performance. So thick film lubrication, it is classified or divided into two parts, that is hydrodynamic lubrication and hydrostatic lubrication. Now first we'll talk about hydrodynamic lubrication. It is defined as a system of lubrication in which the load supporting the fluid film is created by the shape and the relative motion of the sliding surface. So what is this definition? We will understand it by discussing about hydrodynamic lubrication with the help of diagrams. Now here you can see there are three diagrams A, B and C which shows you hydrodynamic lubrication. First, journal at rest condition, journal start to rotate, and the last one is journal at full speed. So basically the term journal used over here is for shaft. This shaft is also called as journal and this outer surface is nothing but the bush. Now initially when the journal is stationary or it is at rest condition, this is the position. This journal is in contact with the bush and W is the load acting on the journal. Now here in between these two there is nothing but lubricating oil. Now as the journal start to rotate, then it start to climb over the bearing surface. It start to climb over the bearing surface or on the bush. So in that case it forces the fluid to flow through the wedge shape. Now here in this figure you can see that as the speed increases, this shaft start to climb over the surface of the bush. It start to climb over the surface of the bush and at the same time it forces the liquid to pass through the wedge shape. So this is the oil wedge form. So this forces it forces the liquid to pass through this wedge shape. Now as continuous flow of oil, it generates the pressure in this region, and this pressure or this oil pressure balance this force W. Here you can see the pressure distribution is generated within the system is around the periphery of the journal. This is the journal and this here in this region the pressure distribution is pressure is generated. So this pressure it balances the W. Now here you can say about bearing that pressure is generated within the system. In case of hydrodynamic lubrication, The bearing itself generates the pressure. Hence, these bearings are called as self-acting bearing. So, as the pressure is generated inside the system, there is no need of pressurized lubricant. Only the need is to supply sufficient and continuous amount of lubricant. Now, as we are saying that shaft inside the bearing, this is called as journal. So these bearings are also called as journal bearings. Now, one more important point about this journal bearing is that they support only the radial load. Hence, you can say that a journal bearing is a sliding contact bearing which works on hydrodynamic lubrication and which supports the load in the radial direction. Next is hydrodynamic journal bearing. Now they are classified into two: full journal bearing and partial journal bearing. Now in case of full journal bearing, here you can see in the diagram that the arc of contact or angle of contact between the journal or shaft and the bush is 360. Whereas in case of partial bearing, the angle of contact between the journal and the shaft is less than 180. It is always 120 degree. There is a differentiation over here. Now full journal bearing, it can take radial load in all the direction. As arc of contact is in 360 degree, it can take radial load in all direction. Whereas in case of partial, it can take simply in the one direction. Only in one direction over here. Here it should be one direction. Then, now full bearing, it is difficult in construction and also it is difficult to supply the lubricating oil. Whereas in case of partial journal bearing, it becomes simple. Construction is simple and easy supply of lubricating oil is possible. Now, as the arc of contact is more, so surface of contact will be surface which is in contact, that will be also more. So there are more frictional losses due to more friction, and in case of partial there is less frictional losses. In case of full bearing, radius of journal, that is radius of shaft, it should be or it is always less than the radius of bearing. So the radius of bearing and radius of shaft is there is a difference, and this difference is nothing but called as a clearance. So there is some clearance between journal and the bush. So these bearings are called as clearance bearing. Full bearing is also called as clearance bearing. Now, in case of partial bearing, the radius of journal is equals to radius of bearing. So the radius of journal and the radius of bearing is equal. So in this case, the shaft is mounted at eccentric distance in order to provide the space for lubricating oil. Now this type of bearing is also called as fitted bearing. In this, full bearing is widely used or it is having wide application than the partial bearings. Now, hydrodynamic journal bearing are basically seen in case of engines and centrifugal pumps. And full bearing is having wide application. Now, we have to talk about thrust bearing. In the previous slides, we have seen about radial bearings which are working on hydrodynamic lubrication principle. Now, we have to see thrust bearing based on hydrodynamic lubrication. Now, first is footstep bearing and second one is collar bearing. These are the diagrams. Here in this, both the diagram you can see this P is acting along the axis of the shaft. Hence, you can say this is nothing but the axial load. So, the bearing which supports the axial load is called as a thrust bearing. So, here in this case, in case of footstep bearing, the end of the shaft is in contact with the bearing surface. This is the end of the shaft and it is in contact with the bearing surface and oil is passed from this passage. Now next is collar bearing. Now in case of collar bearing, same axial load is supported by the bearing. In this, collar is an integral with the shaft which is in contact with the bearing surface. Next we have to discuss about hydrostatic lubrication. Here is the diagram of hydrostatic lubrication. Diagram A shows you the rest position and the diagram B shows you the journal at full speed. Now, in case of hydrodynamic, we have discussed that pressure is pressure is generated itself by the system, whereas in this case, pressure is generated by the external source. And hence it is called as externally pressurized bearing. We'll see how. Initially now, journal is at rest position. So there is a contact between journal and the bush, and W is the load acting on it. So now what happens? Now the external source is used to supply the oil. Whereas in that case, shaft was rotated and then with the increase in speed, the pressure generated was increasing. Now in this case, externally pressurized oil is supplied in the bearing. So from this passage, the oil is flown, pressurized oil is flown over here, and due to that what happens? The shaft starts rotating. As the pressurized oil enter in this passage, it separates out the journal and the bush with a layer of film or layer of lubricant in between it. Hence, now as comparing it with hydrodynamic, you can say in case of hydrodynamic there is some amount of starting friction, but due to external pressurized fluid, there is no starting friction in this case. Directly fluid is supplied and journal and bush is separated. In case of hydrodynamic, there is starting friction. High load carrying capacity. Hydrostatic is having high load carrying capacity, whereas hydrodynamic is having low load carrying capacity. And in case of hydrostatic, now due to pressurized fluid or due to pressure as we have to generate pressurized fluid, so initial and maintenance cost is high due to use of external power source. So you can say that cost will be less in case of hydrodynamic lubrication. So we have seen one definition of hydrodynamic journal bearing. It is defined as a system of lubrication in which the load supporting fluid film is created by the shape and the relative motion of the sliding surface. So in case of hydrodynamic lubrication, pressure generated is due to the shape and the relative motion of the sliding surfaces, which supports the load. Whereas in case of hydrostatic lubrication, pressure is generated by means of external power source. Next we have to discuss about the thin film lubrication. It is the third mode of lubrication. First is zero film, second one is thick film, and the last one is thin film. This lubrication is also called as boundary lubrication. The condition of this lubrication is that there is a very thin film of lubricant and there is a partial metal to metal contact. Now here in the diagram you can see boundary lubrication. A shows you metal to metal contact and B shows the cluster of molecules. What is that we will see. Now this is first surface and this is the another surface or two surfaces which is having the relative motion between them, and the lubricant fluid or lubricant is passed from these two surfaces, in between these two surfaces, which is having a polar molecules. Now polar molecules are nothing but the molecules which are having a permanent separation between positive and negative charges. Now due to this tendency, they can be orient and stick among themselves in a particular manner. So they can form a compact film. Now in case of region B, here you can see now these molecules due to this molecules, due to good cohesive property of this molecule and the poor property of adhesive, they are forming a compact film or a thin layer in between these two surfaces. So here in this case, the metal to metal contact is not there, but again in some region like A, there is seen a metal to metal contact. Hence you can see there is a partial metal to metal contact in case of thin film or boundary lubrication. Now why this happens actually? Because this thin film lubrication, it depends on chemical composition of lubricant basically, as we are saying that lubricant should have polar molecules, so it depends on chemical composition of lubricants and it depends on the surface roughness. So here in this region A, there is a contact due to the rough surface. So on these two properties, thin film lubrication depends. Whereas in case of thick film lubrication, it totally depends on the viscosity, as there is no contact between the two surfaces. There was a there was a lubricating oil, the layer of lubricating oil in between two surfaces. Hence, viscosity was the affecting parameter in case of thick film, whereas chemical composition and surface roughness is the affecting parameter on a bearing in case of thin film lubrication. Now you can say that hydrodynamic bearing, if it operates at low speed and high load condition, then it acts like a boundary lubrication. So the statement is at low speed or at low speed or high load condition, hydrodynamic bearing operates under boundary lubrication. So this is nothing but the thin film lubrication. Now we have discussed about the three modes of lubrication. I hope you have understood. If you have understood, so please like, share and subscribe this video. Thank you.